Is it possible to connect cognitive science and computer science? Imagine that you could develop software which supports classical hardware and on-chip training procedures to create solutions for existing medical and educational tasks. I'm going to explain the hardware which allows cognitive computing and its connection with software-based artificial general intelligence. Hello universe. This is Zahra M.M.A. Sadiq. Please subscribe to learn more about artificial general intelligence which builds a better world. Self-organizing electrochemical processes determine how the brain works. Physical and chemical reactions cause the neurons of the brain to transmit information. The quantum computer, the photonic computer and the neuromorphic computer possess chemical and physical properties. This changes the way these devices process information. Quantum computers perform parallel computations and neuromorphic computers calculate their output based on operations which don't reveal a mathematical pattern. The combination of hardware and AI-based software improves the performance of these devices. It's also possible to combine on-chip training procedures with AI-based software. The two-step approach which combines the hardware and the artificial intelligence-based software extends the scope of the hardware and even on-chip training procedures. The interdisciplinary combination of computer science and the natural sciences extends the scope of neuroscience, physics, and chemistry. These programs improve the disciplines of astronomy, medicine, and mathematics, for example. Software also improves the procedures of brain-computer interfaces and neural interfaces which connect the brain with an external device and alternate the nerve activity. While the brain-computer interface allows the transmission of information in a bidirectional way, neural interfaces only send information to the brain, but they don't receive information from the brain. This technology improves the medical treatment of brain diseases and education. Artificial general intelligence is connected with the field of cognition. Exascale computing designates computational systems which are able to perform 1 billion calculations per second. Computer engineers around the world improve the processing power of computers to develop an exascale supercomputer. These supercomputers possess the processing power of the human brain. Cognition designates the mental procedures including attention, knowledge, memory, decision-making, evaluation, reasoning, and learning. The cognitive autonomous agent, which is a software or hardware agent, manages knowledge. The agent, for example, a legal software agent, uses language. In this case, its knowledge is a representation of the designated object which exists in the real world. This knowledge and the language are also represented as a vector of the artificial neural net in a mathematical way. Pattern recognition describes a cognitive process that matches stimuli with information which the agent memorizes. The active agent takes action and shapes its environment. It's able to learn and to react to its environment and the stimuli it perceives. Cognitive semantics plays an important role in the realm of cognitive computing. Cognitive semantics belongs to the field of cognitive linguistics. Semantics designates the analysis of word meanings and relations between words and knowledge representation. Logic and reasoning structure the process of thinking. They draw conclusions from premises and detect and manage contradictions. A two-step approach which combines the hardware and the artificial intelligence-based software extends the scope of the hardware and even on-chip training procedures. Software also improves the procedures of brain-computer interfaces and neural interfaces which connect the brain with an external device and alternate the nerve activity. The cognitive autonomous agent, which is a software or hardware agent, manages knowledge.